Greetings, CS240 students. This video will show you the idea behind the lab you have where you're supposed to be fixing the program. And I guess it's the first time I've given you a homework where I said, please fix this program, as opposed to please write it starting from some code that I gave you and then put your code here. So it seems to have confused a lot of people. So there are two keys to understanding how to do this. Key number one is that the comments in the program are correct. That's the most important thing. The comments are correct. The code is wrong. Key number two is after I assigned that program, I proceeded to start lecturing about subroutine entry and exit. But subroutine entry and exit was not the basic problem with that program. So that wasn't a hint to be putting subroutine entry and exit in there with all the stack manipulations. So without further ado, here is another program that is not the one I assigned, and it's pretty easy, except it's full of bugs. So I'll now go through it, and by going through it, I hope we illustrate what you need to do. But the key is that it's going to force you to read the code and understand what the code does. That's the idea behind the program, and then you have to fix it. Okay? So that's the idea. It's forcing you to read. All right, so this is a simple program that's a lot like our first couple of programs. It's going to loop through a string of characters, one character at a time. And if you look at this, you'll notice that it's kind of mixed upper and lowercase, right? All right, so we're probably going to need to do something to it. So what it's going to do is it's going to change that message to all uppercase. Except, of course, for the space. The space doesn't get changed. Then it's going to add a punctuation mark at the end. The punctuation mark will be a exclamation point if the sum of the original characters is even. Otherwise, it'll be a question mark. So we're going to have to add up all these characters. Every character, remember, is a number. Okay? So we're going to have to add up all those characters. Got it? All right. Let's get moving. Here's where our program starts. We notice that this stuff, which we now understand about the stack, it needs that it inserted that when we said we were debugging it. And so what are we going to be doing? Well, we're going to be looping through all the characters. So you know what we need to do. You've done this in several labs. You get the address of the first byte into a register, right? And so here's the address of the first byte into a register. We're going to need to add up all the characters. So we need a register to accumulate the sum of all the characters. And that should start out at 0. So the sum of the characters will start out at 0. And we're going to need to get the EAX register to be 0 to start out with. So this will zero out the EAX register. And then we have a loop. And the loop is going to do what you've done before. It gets a character. We're going to, if we hit a 0 at the end, if we hit the 0 over here, we're going to exit the loop. Otherwise, we're going to add the character into the sum. Okay. We're going to see if the character is a blank. If the character is not a blank, so this is an if statement, right? Here's an if statement right here. The compare and the jump. If it's not a blank, we're going to force the character to be uppercase, and we'll look at that again in a moment. And then we're going to save the character back where it came from and advance in the buffer to the next address in memory. Okay, and then that's our loop. When we're done with the loop, we are going to have another if statement to see whether or not it was even. We can check whether it's even by looking at the low order bit. Okay, and then we'll assume if it's even, it's a bang, and otherwise it's odd, it'll be a question mark, and we'll put that into the punctuation part and then print it. So a pretty simple program. Okay, not too bad. For aid in debugging, we have our registers going over here, and we have our message up here. So 53 is the capital S, 61 is the lowercase a, like that, okay? Hex 20 is a blank, like that. And I put just the punctuation mark part over here. So, with the 0. Alright, so we can let her go until it crashes, or we can step through one at a time. Let's just step through for a bit. And what I want is the step into. I don't think is there a button for step into over here? This one, okay. Alright, so before the loop we have to set up our registers. We now know about ESP and EBP, which the debugger wants over there. Alright, so we're going to move the address of the bytes to convert to ESI. So there's our ESI, some address. We're going to put a 0 into ECX because ECX is going to add up a bunch of things. We want to start at 0. And then this should 0 out EAX. All right? Okay, so let's take a look at our registers. What's going on here? So, does ECX contain a 0? No. That's a character 0. We got a bug, right? Okay. All right. No, I mean, if it's numerically, we're adding up numbers. I wanted to make that a 0. Let's just make that a 0. Okay, that's... And what about EAX? Did that contain a 0? Well, OR EAX, if you remember how OR works, 0 or 0 is 0, 1 or 1 is 1. So OR EAX does not change EAX at all. So is there something similar? All right, if I want to 0 it, one thing I could do is I could move, just like we did with the other register. But the other way of zeroing out a register is to do this, exclusive OR, so that the zeros exclusive ORed with the zeros with themselves become 0, and the ones exclusive OR with the ones become 0. So that's a programmer's way to 0 out EAX. So this is two different ways to 0 out a register. Okay? Okay, I should probably, as a comment here, put start at 0. Okay? But the point is that, I mean, if this was the sum, you'd know it as a programmer, you know it starts at 0. And, all right? So that was two instructions where the comment was right. Okay? But the code was wrong. Okay. Ready? Bingo, we crashed. Why did we crash? We crashed right here on line 26. What's wrong? That's a very straightforward. EDI contains what? It contains an address This says go to that address and move the byte into AL. EDI contains 0? Does 0 sound like a good address? Hell no. So what happened? Well, what happened is over here we put the address into ESI. So EDI was the wrong register. All right, let's make this EDI. And we should start from the beginning. So let's start from the beginning. We stop this. Okay. Debug. And let's step. Okay. Now, EDI contains a legitimate looking address now. ECX should become 0. ECX became 0. EIX should become 0. Like that. Okay. Now this should get the first character into AL. The first character up here was a capital S, a 53. EAX was 0. EAX is now 53, which is 0 in the right byte, and all, or 53, a capital S in the right byte. Okay. All right. Now if it's 0, we need to exit, right? So we have a loop, an if statement. We do something to set the flags, and then we go to done, right? So what we have in here now is a capital S. We should not go to done. So step. Oh, crap. How did we end up down here? EAX is 0. But wait a second. It wasn't 0 a moment ago. Okay, here is our problem. We were checking to see whether AL was 0, right? And we did sub AL. Of course the result is 0. There are a lot of things we could do to AL to test it, but subtract sets the 0 flag, right? We want to set the 0 flag without changing it. And we have a couple of ways of doing that. One way to be CMP AL, 0. Compare it to 0. And then we might change this to a jump if equals. That would be if AL equals 0, right? Another thing we could do would be OR AL, AL. ORing something with itself does not change it. And if the result is 0, it was 0 to start with. Okay? So there are a couple ways of fixing it, but that if statement is commented correctly. Okay? If EAX is 0, we're going to jump to done. But the code was wrong. All right? Let's start again from the beginning. Debug. Okay. Here we go. Now AL should contain our capital S. Now we have the flags over here. It says the 0 flag right now. It says right now the 0 flag is on. If I OR AL, which is not 0, then it should stay a capital S. The 0 flag is now off. I'm going to JZ to done, which means I won't. Okay. Now I'm going to accumulate this character into the sum. All right, here's an add instruction. That looks good. Okay. And now I'll see if it's a blank. I compare it to a blank. That sounds good. If it's not equal to the blank, then I'm not going to uppercase it. If it is equal to the blank, or wait a second, then I'm going to do that. Okay. So What's going on here? All right, so the if statement's correct. If it was a blank, then I didn't do the and. Okay, no, wait a second. If it is a blank, I skipped over this. If it's equal to a blank, I want to skip over this. Darn. Okay, let's go back. Start again. Okay. It's equal to a blank, which means I don't want to jump. I mean, it's not equal to a blank. It's not equal to a blank, which means I want to do the then part of the if. So this is an if. If it's equal to a blank, then do the. If it's not equal to a blank, then jump around the then part. That's how when we build ifs in assembler, we got to negate the condition and jump around the then part. So it's equal to a blank. It's not blank, so we don't want to jump if it's not blank. It's equal to, okay? That's great. Okay. So force the character to be uppercase. No problem, it's already uppercase. Now we want to save the character. We want to advance to the next character of input. Go back to the top. Okay, fetch the next character. What? All right, what happened? All right, well, here's what happened. Does that look like our address? Remember, our address was 80 something or other, really long? Somehow we clobbered EDI. Where did we clobber EDI? EDI is our address, right? EDI is our address. We're going to touch the memory at that address. That was the memory at that address. All right, here's where we clobbered EDI. So is that, wait a second, EDI is our address. Why are we anding something into the address? Well, the comment says we're trying to make the character uppercase, right? What register is the character in? Well, the character's in AL. Oh, crumb. Okay. All right. So time to start over, right? Okay. Anyway, you get the idea. This is what I'm asking you to do in this homework. You've got to, I gave you a handout. You have to read the code. All right? The next audio, or the next video is going to be a little bit more specific to that homework. Or there will be another one which is a little bit more specific to that homework that'll help you through it. But what I've shown you here is the basic idea. But just to finish this up and not go through it with so much pain, okay, for the characters over here, just so you remember, ASCII, okay, lowercase r, hex 612 77 alpha or something like that, okay, is A to Z, and the uppercase 0x41 to 5 alpha. And if we take a look at what these are in binary, 61 is 0, 1, 1, 0, 0, 0, 1, 2 is 0, 1, 1, 1, 0, 1, 0, 1, 0. And 41 is 0, 1, 0, 0, 0, 0, 0, 1, 2, 5 alpha, 0, 1, 0, 1, 1, 0, 1, 0. So if we look at these characters in binary, we notice that the difference between the uppercase and the lowercase is that bit. So we had this in an earlier lab. If I want to convert a number from uppercase to lowercase, what I need to do is I need to zero out that bit. Or from lowercase to uppercase. If I want to convert a letter to uppercase, I just have to zero out that bit. If that bit was already 0, we're fine. If that bit is not, then we need to zero it out. So I do want to AND with something, but it's not with hex 20. I want to AND with so we'll put it over here. I want to AND with 1, 1, 0, 1, 0, 0, 0, like that. Okay? So if I AND this one with this one, then all the bits are saved except for that bit. Okay? So that's my AND mask. In hex, that's what? That's going to be BF. So here, instead of hex 20, I wanted to AND with BF. Hex 20 was the opposite. Okay, so that's another bug. We're almost done. Okay? All right. Now down here, I needed to save the character. All right. I'm clearly not saving the character because I'm not touching memory. So if it says save the character back into memory, I need to do what? I need to, well, first of all, the character was in AL. And second of all, I need to go back into memory. Right? All right. I need to advance to the next character. This is actually going backwards in memory. Right? That doesn't sound good. Okay, jump to top. That does go back. Okay, so you get the idea. All right? So you could pretty much debug these by just reading the code, but probably you're going to have to be running it at the same time to see what it's doing. Okay? The bugs are kind of dumb, but what can I tell you? It's a beginning assembler class, so your job is to find the dumb bugs. All right, so and down here is an example where I'm trying to put BL into punk. That move is backwards, right? Okay. I need to put BL into punk. It's got to be the other way around, right? All right. So the program that you have is full of errors, and some of the errors are a lot like the ones I just showed you, and some of them are just completely different. But the spirit of the program is the same. So that's the spirit of your homework. All right. Thank you.